All right, class, we're going to go over what you see here is our kind of learning topic, number one aspect of this part of the worksheet. We looked at the previous page at the difference between a population and a sample, and a population distribution and a sampling distribution. So here we're going to focus on what a parameter is and a statistic. So this goes hand in hand with population and sample. So think about statistic as the number that describes a sample, so statistic, sample, and a parameter as the number that describes a population, parameter, population, right? So S for sample, statistic, parameter, P, population, P. And there are symbols that go with it. So if I think about the symbol for parameters, they are these guys here. So look at the mu for means, a P for proportion, and that circle with the line at the top for standard deviation. It's a Greek letter there. So you've got these, and they are specific to those types of data, right? Means, proportions, and then standard deviation. And then below that, right, we have our symbols for statistics, right? So a statistic, if we're dealing with a sample mean, that is that X bar there. We're dealing with a sample proportion, that is a P with a hat on top, we call that P hat. And then a sample standard deviation, that's the S, okay? And those symbols are very important in differentiating what I'm talking about. And we need all that information when we answer questions about samples, sampling distributions, and populations. So when we look at this question down here, this check your understanding question, and it says to determine how much homework time students will get in class, Miss Lynn has a student select an SRS of 20 chips from a large bag. SRS means simple random sample. That's the way they sampled these 20 chips, randomly taking them from a large bag. The number of red chips in the SRS determines the number of minutes in class students get to work on homework. So however many red chips you take out, that's how many minutes that they were going to get for their homework. Mrs. Lynn claims that there are 200 chips in the bag and that 100 of them are red. So thinking about 100 out of the 200 are red for the sampling purposes. When Jenna selected a random sample of 20 chips from the bag without looking, randomly picked them out, she got 7 red chips. Does this provide convincing evidence that less than half of the chips in the bag are red? So 7 out of 20, definitely less than half, when Miss Lynn said that there are 100 out of 200. Now, this is kind of getting evidence off of, a sample, evidence about the population. That's something that we're going to get to later. Today, and in this video, we're going to focus on just identifying the parts to this problem, the information that we have, and what that information is, because that's really important. We need to be able to do that in order to get to this, evidence piece. All right, so let's talk about identifying the population, the parameter, sample, and statistic, because that's the information that we want to be able to differentiate between to start. So let's go with the population. So population here would be the whole group. And in this case, population from which we selected were these 200 chips, right? That's how many total chips were in the bag. So when I talk about population, and I know the number, you include the number. If you don't know the number, you just say all, but you do want to identify what it is we're talking about. In this case, it's not just 200 people, but it's actually chips that are the population. Okay. And then you can go down to the sample part. And when we look for the sample, you want to see the subgroup that you were selecting from that population. And in this case, they gave us the type of sampling method, the SRS, and how many were taken from the bag. So we have a sample size of 20. So if we have that, we want to include that. And what is it? They're 20 chips. You want to have that context. And did we know how they were taken? Yes, so you can say they were randomly chosen. If you don't know that information, that's not important if you're just identifying the sample. But it, of course, if we go back to chapter 4, we can remember that a random sample is important. Okay, and we'll get to that when we want to get to the evidence piece. So that's differentiating between what the population is and what the sample is, which is super important because we always want to be able to give that context. And then what information are we gathering from both of those things? So that's where we get to the parameter piece. So let's take a look at what a parameter is in this context. So if we look at this and we're looking for the parameter, we're looking at proportions. Red chips is not quantitative, it's categorical. So we actually measure that as a proportion. So if we're looking at the full scope of our population, there's 200 chips, and how many were red in that scenario? There were 100 that were red. So if I'm talking about a parameter here, it's the symbol P. And what is a P? It's the population proportion. And in this case, we actually knew what that is. That's 50 because there's 100 out of 200. A lot of times you may not have that information. So when you define a parameter, you're going to define it in words. So what are the words that you're going to use for P here? What's the context? Well, that's what the words that we would use would be, we would call P the true proportion of red chips. And we use that word true to describe our population because that's and if you don't use true, but you say population, that's enough. Or if you say the proportion of all red chips, right, that's another way you could talk about this in terms of the population. So that's another way you can talk about it, okay? It's always good to be able to identify the context of your problem. So what is P talking about? It's not just 0.50. 0.50 is the proportion of all red chips. 50% of them were red. So there you have it. That's the words. Those are the words. Now we can go to the statistic, which is talking about the sample. So with the parameter, I was focused on the population. With the statistic, I'm focused on the outcome of my sample. And that's the symbol P hat. We talk about sample. Okay? I just covered up the P hat there, but you get the idea. So if you look at P hat, if you ever see that symbol, you're talking about a sample proportion. And in this case, our outcome was 7 out of the 20. All right, and that's the outcome there. In words, you would say the sample proportion of red chips is 0.35. And that's super important because now I can use that to compare that to the population, and we can start to figure out, if, Miss Lynn's claim is legit or not. Okay, so first, figure out which goes where, right? What's the population? What's the sample? Get your context, and then you can decide, what parameter we're looking at, what number describes the population. In this case, it was the proportion of red chips. Okay, and same with the statistic. What sample, what outcome in the sample did we get? And there you have it.